Welcome friends. In this module we discuss skewness and kurtosis. Skewness. In everyday language, the terms skewed and askew are used to refer to something that is out of line or distorted on one side. For sets of observations, the way in which the observations are distributed about the central value may differ. If they are distributed exactly on either sides of the central value, the distribution of the observations is said to be symmetric. Otherwise, it is said to be skewed. Hence, the skewness is the characteristic of lack of symmetry for a given set of observations. The shape of the frequency curve for a given set of observations indicates the skewness of the set. A bell-shaped frequency curve say that the distribution is symmetric. A shape of frequency curve with an asymmetric tail extending out of the right is referred to as positively skewed or skewed to the right, while a shape of frequency curve with an asymmetric tail extending out of the left is referred to as negatively skewed or skewed to the left. For a symmetric distribution, mean, median and mode are coincides, that is, mean equal to median equal to mode. For a positively skewed distribution, mean greater than median greater than mode, and for a negatively skewed distribution, mean less than median less than mode. The following are the examples for the frequency curves of symmetric or normal, positively skewed and negatively skewed distributions. Here mean equal to median equal to mode for symmetric distributions. Here mode less than median less than mean, positively skewed distribution. Here mean less than median less than mode, negatively skewed. Measures of skewness. The measure of symmetry of the given set of observations is the measure of skewness. The following are some important measures of skewness. 1. Pearson's measure of skewness. Coefficient of measure of skewness suggested by Carl Pearson is denoted by J, where J equal to mean minus mode by SD or J equal to 3 into mean minus median by SD. The value of J ranges in between minus 3 and plus 3. J greater than 0 for positively skewed, J less than 0 for negatively skewed and J equal to 0 for symmetric set. 2. Quartile measure of skewness or Bowley's measure. Bowley suggested the coefficient measure of skewness based on quartile deviations as Q equal to Q3 minus M minus of M minus Q1 divided by Q3 minus Q1, that is Q3 plus Q1 minus 2M divided by Q3 minus Q1. Here Q1, Q3 are the first and third quartiles of the given data and M is the median or second quartile. Q ranges in between minus 1 and plus 1. Q greater than 0 for positively skewed, Q less than 0 for negatively skewed and Q equal to 0 for symmetric observations. 3. Measure of skewness based on moments. Moments are statistical measures to measure the fundamental characteristics, center tendency, dispersion, skewness and kurtosis of a set of observations. Let x1, x2, etc. xn are the observations and let a is any constant and r any non-negative integer, then mu r of a equal to 1 by n summation over I xi minus a all raised to r is called the rth moment of x about a. When a equal to 0, then mu r dash of 0 equal to 1 by n summation over I xi minus 0 all raised to r, which is known as the rth raw moment of x and is denoted by mu r dash, where mu r dash equal to 1 by n summation over I xi raised to r. When a equal to x bar, then mu r of x bar equal to 1 by n summation over I xi minus x bar all raised to r is known as the rth central moment of x and is denoted by mu r, where mu r equal to 1 by n summation over I xi minus x bar all raised to r. Let x1, x2, etc. xn are the observations with corresponding frequencies f1, f2, etc. fn, then mu r of a equal to 1 by capital N summation over I fi into xi minus a raised to r. is called the rth moment of x about A. The rth raw moment of x mu r dash equal to 1 by capital N sigma over I Fi into xi raised to r, and the rth central moment of x mu r equal to 1 by capital N summation over I Fi into xi minus x bar all raised to r. We have x bar equal to 1 by capital N sigma Fi xi, that is equal to mu 1 dash as a measure of central tendency, and the second central moment mu 2 equal to 1 by capital N summation over I Fi into xi minus x bar all square, which is the variance is a measure of dispersion. Coefficient measure of skewness based on moments denoted by beta 1, that is equal to mu 3 square by mu 2 cube, or gamma 1 equal to square root of beta 1. Mu 2 and mu 3 are the second and third central moments of the observations, where mu 2 equal to 1 by capital N summation over I Fi into xi minus x bar all square, and mu 3 equal to 1 by capital N summation over I Fi into xi minus x bar all cube. But beta 1 is a ratio of two non-negative quantities, which is always non-negative. If mu 3 equal to 0, then beta 1 equal to 0. Now the distribution is said to be symmetric. Beta 1 greater than 0 indicates the distribution is skewed. Then observe the sign of mu 3. If mu 3 is positive in sign, the distribution is positively skewed, and if mu 3 is negative in sign, the distribution is negatively skewed. Problem. Find out Carl Pearson's coefficient of skewness of the wage distribution of 200 employees of a company. Wage 70 to 80, 80 to 90, 90 to 100, 100 to 110, 110 to 120, 120 to 130 and 130 to 140. The corresponding number of persons 10, 15, 35, 40, 50, 30 and 20. Solution. Carl Pearson's coefficient of skewness J equal to mean minus mod divided by standard deviation. Mean x bar equal to 1 by capital N summation over I Fi xi, mod equal to L plus C into F1 minus F0 divided by F1 minus F0 plus F1 minus F2. Standard deviation equal to square root of 1 by capital N summation over I Fi xi square minus x bar square. Necessary calculations follows. The classes 70 to 80, 80 to 90, 90 to 100, 100 to 110, 110 to 120, 120 to 130, 130 to 140. The corresponding frequencies 10, 15, 35, 40, 50, 30 and 20, where total frequency is 200. Mid values of the classes x values 75, 85, 95, 105, 115, 125 and 135. Fx values 750, 1275, 3325, 4200, 5750, 3750, 2700. Total 21750. Fx square values 56,250, 1,08,375, 3,15,875, 4,41,000, 6,61,250, 4,68,750, 3,64,500, where the total 24,16,000. Mean equal to 21,750 divided by 200, that is 108.75. Standard deviation equal to square root of 1 by capital N summation over I Fi xi square minus x bar square, that is square root of 1 by 200 into 24,16,000 minus 21,750 divided by 200 square, that is 15.92. Here capital N equal to 200, maximum frequent class is 110 to 120. This is taken as the model class. Then F0 equal to 40, F1 equal to 50 and F2 equal to 30. Hence mod equal to L plus C into F1 minus F0 divided by F1 minus F0 plus F1 minus F2, that is 110 plus 10 into 50 minus 40 divided by 50 minus 40 plus 50 minus 30, that is 113.33. Coefficient of skewness J equal to 108.75 minus 113.33 divided by 15.92, that is minus 0.288. This gives the distribution is negatively skewed. Problem. Calculate the quartile coefficient of skewness for the following data showing the mother's age and number of live births recorded in an hospital. x 10 to 14, 15 to 19, 19 to 24, 25 to 29, 30 to 34, 35 to 39. The corresponding frequency is 3, 14, 38, 26, 12 and 7. Solution. Quartile coefficient of skewness Q equal to Q3 plus Q1 minus 2m divided by Q3 minus Q1. The given classes are adjusted as 9.5 to 14.5, 14.5 to 19.5, 19.5 to 24.5, 24.5 to 29.5, 29.5 to 34.5 and 34.5 to 39.5. The frequencies 3, 14, 38, 26, 12 and 7. The less than cumulative frequencies 3, 17, 55, 81, 93 and 100. Here capital N equal to 100. Class in which n by 4th, that is 25th observation lies is 19.5 minus 24.5. Class in which n by 2th, that is 50th observation lies is 19.5 to 24.5. Class in which 3n by 4th, that is 75th observation lies is 24.5 to 29.5. Hence, Q1 equal to L1 plus n by 4 minus M1 into C1 by F1, that is 19.5 plus 100 by 4 minus 17 by 38 into 5, that is 20.55. Q3 equal to L3 plus 3 n by 4 minus M3 into C3 by F3, that is 24.5 plus 3 into 100 by 4 minus 55 into 5 by 26, that is 28.35. Median Q2 equal to L2 plus n by 2 minus M2 into C2 by F2, that is 19.5 plus 100 by 2 minus 17 into 5 by 38, that is 23.84. Then Q equal to Q3 plus Q1 minus 2m divided by Q3 minus Q1, that is 28.35 plus 20.55 minus 2 into 23.84 divided by 28.35 minus 20.55, that is 0.156. The age distribution is positively skewed. Kurtosis. Majority of the frequency curves are bell-shaped, more or less symmetric and unimodal, but the concentration of observations in the neighborhood of mode may differ. If the frequency curve is almost same in shape to the graph of the function f of x equal to 1 by root 2 pi e raised to minus x square by 2 for minus infinity less than x less than plus infinity, then the curve is said to be a normal curve. The peakedness or flatness of a frequency curve in comparison with the normal curve is known as kurtosis. Carl Pearson called measure of kurtosis as a measure of convexity of the frequency curve. He introduced three broad patterns of peakedness of a frequency curve. If more observations are concentrated in the neighborhood of mode, the curve becomes more peaked than the normal curve and the distribution is said to be leptokurtic. Relatively less concentration of observations in the neighborhood of mode makes the curve more flat than the normal curve. Then the distribution is said to be platykurtic. The distribution with the frequency curve almost same to the normal curve, it is said to be mesokurtic. The shapes of different types of frequency curves are given here. M for mesokurtic, L for leptokurtic, P for platykurtic. Measures of kurtosis. The measure of peakness or flatness of the frequency distribution is the measure of kurtosis. Following are the various measures of kurtosis. 1. Measure of kurtosis based on moments. Coefficient measure of kurtosis based on moments beta 2 equal to mu 4 divided by mu 2 square or gamma 2 equal to beta 2 minus 3. Mu 4 and mu 2 are the fourth and second central moments of the set of observations, where mu 4 equal to 1 by capital N summation over I fi into xi minus x bar raised to r and mu 2 equal to 1 by capital N summation over I fi into xi minus x bar all square. Beta 2 greater than 3 for leptokurtic, beta 2 equal to 3 for mesokurtic and beta 2 less than 3 for platykurtic. 2. Measure of kurtosis based on quartiles. Coefficient of kurtosis k equal to 1 by 2 into q3 minus q1 divided by q 0.9 minus q 0.1, where q3 and q1 are the first and third quartiles. Q 0.9 and Q 0.1 are the observations which comes at the 9 n by 10th and n by 10th position when the observations are arranged in ascending order of magnitude, or they are called the 9th and 1st deciles. For a mesokartic distribution, K will be near about 0.25. Problem. Age distribution of a sample of 200 smokers of a village is as follows. Find the coefficient of kurtosis based on quartiles. X 10 to 19, 20 to 29, 30 to 39, 40 to 49, 50 to 59, 60 to 69, 70 to 79. Corresponding frequencies 22, 43, 62, 38, 29 and 6. Solution. Coefficient of kurtosis K equal to 1 by 2 into Q3 minus Q1 divided by Q 0.9 minus Q 0.1. The classes are adjusted as 9.5 to 19.5, 19.5 to 29.5, 29.5 to 39.5, 39.5 to 49.5, 49.5 to 59.5, 59.5 to 69.5 and finally 69.5 to 79.5. Corresponding frequencies 22, 43, 62, 38, 29 and 6. Less than cumulative frequencies 22, 65, 127, 165, 185, 194 and 200. Here capital N equal to 200. Class in which n by 4th, that is 50th observation lies is 19.5 to 29.5. Class in which 3 n by 4th, that is 150th observation lies is 39.5 to 49.5. Class in which n by 10th, that is 20th observation lies is 9.5 to 19.5, and class in which 9 n by 10th, that is 180th observation lies is 49.5 to 59.5. Hence, Q1 equal to L1 plus n by 4 minus M1 into C1 by F1, that is 19.5 plus 200 by 4 minus 22 into 10 by 43, that is 26.01. Q3 equal to L3 plus 3n by 4 minus M3 into C3 by F3, that is 39.5 plus 3 into 200 by 4 minus 127 into 10 by 38, that is 45.55. Q 0.1, that is L 0.1 plus n by 10 minus M 0.1 into C 0.1 by F 0.1, that is 9.5 plus 200 by 10 minus 0 into 10 by 22, that is 18.59. Q 0.9 equal to L 0.9 plus 9 n by 10 minus M 0.9 into C 0.9 by F 0.9, that is 49.5 plus 9 into 200 by 10 minus 165 into 10 by 20, that is 57. Coefficient of kurtosis K equal to 1 by 2 into Q3 minus Q1 by Q 0.9 minus Q 0.1, that is 1 by 2 into 45.55 minus 26.01 by 57 minus 18.59, that is 0.2544. Since K is almost near to 0.25, the curve is almost mesokartic. Problem. The first four central moments of a set of observations are given as 0, 5.6, 2.4 and 28.4. Discuss the coefficient of skewness and kurtosis of the distribution. Solution. Here we can use the coefficient of skewness and kurtosis based on moments. Based on moments, the coefficient of skewness beta 1 equal to mu 3 square by mu 2 cube and the coefficient of kurtosis beta 2 equal to mu 4 by mu 2 square. Given mu 1 equal to 0, mu 2 equal to 5.6, mu 3 equal to 2.4 and mu 4 equal to 28.4. Hence, beta 1 equal to 2.4 square by 5.6 cube, that is equal to 0.0327, and here mu 3 greater than 0. Since beta 1 greater than 0 and the third central moment is positive in sign, the distribution is slight positively skewed. Coefficient of kurtosis equal to beta 2, that is mu 4 by mu 2 square, that is equal to 28.4 by 5.6 square, that is 0.906, which is less than 3. Since beta 2 less than 3, the distribution is platykartic. Now it is the time to summarize. The fundamental characteristics of a set of observations, skewness and kurtosis, are discussed in this module. The idea of moments is also introduced. Various measures of skewness and kurtosis are explained. Problems are solved to illustrate the measures of skewness and kurtosis numerically. Before the next session, try to solve the following questions. Compare the skewness of two sets of data using the following information. Set 1, mean equal to 140, median equal to 135, variance equal to 900, Q1 equal to 55 and Q3 equal to 200. Set 2, mean equal to 145, median equal to 142, variance equal to 1600, Q1 equal to 45 and Q3 equal to 230. Question 2. Calculate Pearson's coefficient of skewness for the following data of triglyceride present in blood samples of 50 patients. Triglycerides 5 to 15, 15 to 25, 25 to 35, 35 to 45, 45 to 55 and finally 55 to 65. Number of patients 8, 11, 14, 8, 5 and 4. Question 3. Cholesterol levels observed for 86 patients of a hospital is as follows. Cholesterol level 100 to 125, 125 to 150, 150 to 200, 200 to 250. Cholesterol level 100 to 125, 125 to 150, 150 to 200, 200 to 250 and 250 to 300. The corresponding number of patients 4, 8, 34, 28 and 12. Calculate the quartile coefficients of kurtosis. Question 4. For a set of observations, the first 4 central moments are given as 0, 18.5, 9.7 and 69.7. Obtain the coefficient of skewness and kurtosis. Hope you enjoyed the session. See you next time. Until then, goodbye.